Guys, welcome to Mobilemaths with Kamchirai. Today we are looking at subject formula 6, whereby we are looking at some formulas that you come across in physics, in mathematics, in motion, mechanics. So for starters, I've got here the pendulum of a compound, the period of a compound pendulum, which is given by the formula T is equals to 2 pi square root of h squared plus k squared over gh, and we want to make k the subject of formula, and they said take pi to be 10. Okay, so what we do here is this: we are going to solve this one. First of all, let's write our formula. Okay, so for the first thing, we are going to remove the square root. To remove the square root, we said it's the same as multiplying by 2 everything. Okay, because we said t is equals to 2 pi square root, and we can say our square root is h squared plus k squared over gh is the same as to the power of half, like that. So to remove the half, we said we multiply by 2 over 1 here. So we are going to multiply everything by 2 over 1. So this one by 2, by 2, by 2. So these will cancel off each other. So we'll get t squared is equals to 2 squared, we get 4, then we have got pi squared here. Then multiplying by h squared plus k squared over gh. Okay, like this. Now I'm going to remove the 4 pi squared there. So I'll divide everything by, I'm going to divide both sides by 4 pi squared, here by 4 pi squared. Okay, when I do that, this side they cancel off each other and will remain with this thing only. So we have, now it becomes t squared over 4 pi squared is now equal to h squared plus k squared over gh, like this. Okay, now I think I can, this is gh, I wrote gg. So now I'm going to multiply everything by, I'm going to remove this gh, so I'll multiply everything by gh, everything by gh. On the left side, they are going to cancel off, on the right side, they are going to cancel off each other there. So we'll remain with t squared times gh over 4 pi squared is equal to h squared plus k squared, like that. Okay, now we have reached a point whereby we can even take the h there. This h can go this side and it becomes a minus. So I have t squared gh over 4 pi squared minus h squared is equal to k squared, like that. Okay, to get my k, I multiply everything by, this is 2 over 1 by half. Okay, so I'm going to multiply everything here by half. So this side will cancel off each other. So our k is equal to, let me write the k here. K is equal to square root of everything, that everything, t squared gh over 4 pi squared minus h squared. So like that, this is how we have made the k the subject of formula. When you've done this, you have reached the k. But remember, we were given our pi is equal to a 10. So we are going to substitute by 10 there. So when we substitute by 10, let's substitute by 10. They gave us our pi squared is equals to a 10. The question was saying pi squared here. Yes, it was saying pi squared here. Okay. So our pi squared is equals to 10. So we are simply going to substitute here with a 10. When we substitute here with a 10, we'll get 4 times 10, and that becomes a 40. So our k is equal to square root of all of that. I'm going to use bracket t squared gh over 40 minus h squared. Why bracket? So that you know everything is under the square root sign. Okay, So that's the final answer there, guys. Let's move on to another question. The question that I have next is of interest. So we want to make T and P subject of formula. So we are going to start with, we can even start with P. Okay, it's easy. That's why I'm saying P. For me to get P alone, I can simply take this one to this side. It becomes a minus. So my A is going to be A minus P R T over 100 is equal to a P. You see why I said it's easier? So our P is equal to A minus P RT over 100, like that. Now let's make T the subject of formula. Making T the subject of formula, I can say, I'm going to start from the equation there. Let me rewrite the equation. We have our equation as A is equals to P plus PRT over 100, and we want to make T the subject of formula. I'm going to take this one this side, it becomes a minus, so I'll have A minus P is equal to PRT over 100. To remove the 100 there, I multiply everywhere by 100, so I multiply here by 100 and also here by 100. So these will cancel off each other, and here I'll have 100 multiplying A minus P here, like that. This is going to be equal to PRT. Okay, and I want to remain with a T, so I will divide both sides by PR, divide by PR, like that, such that they can cancel off each other. This PR, then my T is equal to 100 A minus P over PR. It's fine like this. You have made T the subject of formula. Let's have another example. Oh, this one is the motion equation. V squared is equal to U squared plus 2AS. We want to make S the subject of formula. I think I'm going to start again with U. Let me start with U because it's alone there. So I'll take this one, this side, it becomes minus. So I'll have V squared minus 2AS is equals to U squared. Okay. To get my U, I'm going to get square root of this. So I'm going to just say this is the square root of this, square root of this, so that these ones will cancel off each other. It's the same as what we have been doing. U to the power of 2 over 1 times 1 over 2 is this square root sign there. Okay, it's the same thing. So our U becomes, our U is equal to square root of V squared minus 2AS. That's how we do it for our U. Let's do it for S. Okay, for S, I'll rewrite my equation. V squared is equals to U squared plus 2AS. Okay. Now I want to find for S. I will take my U this side. Let's take my U this side, U this side. I'll have V squared minus U squared is equals to 2AS, like that. Then to get my S, I'll divide both sides by 2A, by 2A. Okay, these will cancel off each other, this 2A and that one. So our S is equals to, S is the distance. I'm not doing physics there. So S is equals to V squared minus U squared over 2A. This is the formula when you want to find your distance, when you are given velocity and acceleration there, initial velocity and final velocity there. Okay guys, I don't want to talk about physics. Let's meet in the next video. Okay, bye bye.